So let's say you found a skeleton. How would you tell if it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube, the Dapper Dinosaur here. Today we're taking a look at an episode of the Creation Podcast, an Institute for Creation Research production featuring Dr. Timothy Clary, who does in fact have a real PhD, something you always have to check on with creationists. Also present is interviewer Trey Bowling, who's basically just a stand-in for a friendly audience. That means I expect to be annoyed by him, because I am not a friendly audience, I am an antagonistic audience. Either way, we'll pick up after the intros.
So we're going to be talking about erosion.
I know what you're thinking. Erosion is so simple, there's no way creationists can really screw this up. Trust me, they can. Just remember, they think that the Grand Canyon is entirely a flood spillway, even though that's just physically impossible.
So when I think of erosion, I think of my high school years, and they're like, erosion is what happens to, rocks and dirt, and it just wears things down, and even like concrete gets eroded.
Gold star to Trey for knowing basic words.
There's water erosion, there's air erosion, right? Let's just wipe all that away. We're not going to think about what I learned in high school. What do you say that erosion is?
Well, I would just say it's the removal of material, whether it's the rock or sand or whatever. It's the erosion is the actual, you can talk about weathering. Weathering breaks stuff down, but the erosion is actually the removal of that material from one place to another place.
So far, so good. Clary is correct.
So erosion affects our planet, and not just our planet, but I guess every terrestrial planet that's out there.
Yes, in fact, look at this. A huge section of Mars' northern hemisphere is an actual flood spillway. Notice how little like the Grand Canyon it looks? Do I have a point? Just that I want to drive home how even erosion is something that creationists routinely screw up.
But we're focused on Earth, and so we do experience erosion here.
Well, the other planets probably don't erode if they don't have an atmosphere.
And here is where the podcast just starts going off the rails. Airless worlds do indeed have erosion and weathering. High-energy impacts, whether from cosmic rays, gamma rays from the sun, or micrometeorites, break down rock, and gravity will indeed remove particles from their present location in such a situation. And that can be helped along by quakes, which are known to happen on the moon with some frequency as a result of it cooling and contracting. Now, this is glacially slow even compared to glaciers, but it's happening. That being said, an airless world will never have landscapes dominated by erosion such as the Grand Canyon or the channeled scablands.
You know what, Dr. Clary?
So,
no.
No.
You're good.
They probably don't erode like, the way we think of it. There's things that are going to hit them going through space. And
That's
so
true.
there's going to be some impacts and things like that. And there is some.
Well, this is off topic, but aren't there storms on some planets?
Yes, in fact, this is a whirlwind on Mars, and the famous red spot on Jupiter is basically a hurricane larger than the whole Earth.
Well, there are. See, some of them do have an atmosphere, like Jupiter and Venus, but Mercury doesn't really erode.
Okay, so it's just sitting there, nothing to erode it.
It gets really hot on one side, really cold on the other, because it rotates so slowly. But.
Yeah.
In fact, Mercury spins on its axis 3 times for every 2 orbits of the Sun. But yes, it does erode. Now, it suffers fewer micrometeorite impacts than the Moon, as so close to the Sun, the solar wind is many times stronger and it removes most such particles. But on the other hand, it is blasted by far more high-energy particles per unit area from the Sun than the Moon is. I have no idea how both of those effects will combine to mean either more or less weathering on Mercury than the Moon, but I'm also getting a bit tired of all this off-topic space stuff when we're here to talk about erosion on Earth, which is more interesting than erosion on the Moon or Mercury. That being said, erosion on Titan would probably be quite interesting.
Yeah, other than the solar wind maybe blasting off some. Well, if it did have an atmosphere at some point after the creation.
Oh yes, maybe before the flood, Mercury had an atmosphere. Of course, this does bring up the question of when in the young Earth creationist timeline do all the craters hit it? Was it created with impact craters from impacts that never happened? If not, there must have been some time after the creation that was a hell of a lot busier in the solar system than what we see today. There are 414 craters on Mercury that have been named, but that is only a tiny percent of the total number. The Moon has more than 5,000 craters that are 12 miles across, or more, and probably more than 1 million that are half a mile across or larger, and perhaps 500 times as many as that are larger than 10 meters wide. Each and every one of these impacts has to be fit into some time period before the start of the historical record, because if the, say, 500 million plus craters on the Moon had occurred during that time, it would mean more than 300 impacts a year on average. Now, since about half of that would be on the far side of the moon, that means only about 155 per year would be on the side visible to humans. And if, say, about half a week on either side of the new moon would make the impacts more or less impossible to see, that still means about 116 impacts per year should be noticeable to humans. But no one ever bothered to write about the fact that every third day or so there was a flash of light on the moon. At the very least, by the time the telescope was invented, this must have calmed down. But more significantly, the rate of impacts on the moon is also tied to the rate of impacts on Earth. For the moon to have so many impacts, it must have moved through a space with an appropriate density of objects with which to collide. But the Earth and the moon move through basically the same space, meaning that even if we spread all these impacts out across recorded history, we're still looking at an impact somewhere on Earth every other day or so, including many impacts about once a decade or so that will leave behind a crater that's about a mile across. Now sure, plenty of objects that impact the moon would be turned into dust in Earth's atmosphere, but even if we cut the impacts at 25% to account for this, that's still almost one impact a week. We don't have the craters to account for this. If we want to just push all of these impacts into the flood year, then we're looking at impacts occurring about 16 times per second on the moon, and if we're generous, about 4 times per second on Earth. Funny how the creationist flood models don't bother talking about the fact that an asteroid or similar was slamming into Earth every quarter second. Just one more insurmountable source of heat for the heat problem, I guess.
It's gone now. So there's maybe different scales of erosion.
Maybe different.
But we're talking about Earth. So let's get back to Earth.
I love the little side tangent. Thank you, though.
After like 2 minutes of waffling about space, are we finally going to talk about the point of the whole thing? Talons crossed.
I don't want to be incorrect. Okay.
Oh, the irony of young Earth creationists not wanting to be incorrect. Spoiler alert. If you don't want to be incorrect, you shouldn't belong to a group of people who are routinely 7 orders of magnitude off on their estimates.
So we have seen on our planet something very different than what we would see on the other planets, I guess.
I don't know. We've seen a lot of water and wind erosion on Mars. There are even waterborne sedimentary rocks on Mars, and to get sedimentation in one place, you need erosion in another place. They're sides of the same coin.
And that is rapid erosion. We see things like floods or catastrophes, whatever, that cause rapid erosion to happen. And so this kind of stands in contrast to the supposed millions or billions of years of layers that supposedly our Earth has.
That is in no way at odds with science. Floods do indeed happen, and they do indeed move a lot of sediment. There are flood deposit turbidites all over the geological column. No one is denying this. The problem is what to do with all the rock that cannot have formed this way. Sure, the channel's scablands are a flood spillway, but the Grand Canyon can't have been formed in less than hundreds of thousands of years. The Aeolian sandstone of the Dakota Formation in Mongolia can't have been formed in a flood. The subaerial ash of ashfall beds in Nebraska can't have been formed in a flood. That floods have happened on Earth says nothing on its own about the age of the Earth, but the existence of rocks that physically cannot have formed in a catastrophic manner does.
Specifically, I think of like cliff collapses, which is because, you see that cliff and then if you talk to someone who's, uniformitarianist and they'll be like, oh, that cliffside is 4.35 billion years old. Not that old. That's as old as I think the Earth is. But then if it collapses, it's gone. And then it's like, now what?
Now, what it is that they're not telling you is how long that specific rock has been the face of the cliff. That's hard to determine. What they're telling you is when that rock formed. If I take a rock of absolutely known age, say a rock formed in the eruption of Kilauea in Hawaii from July 10th through 17th, 1961, but then break off some of it and toss it into the ocean, the rock remains about 60 years old. Similarly, when you hear that the White Cliffs of Dover are 70 million years old, that doesn't mean that there were cliffs there 70 million years ago. That means that's when the chalk that makes up the cliffs formed. It didn't start out as a cliff, that happened later. I really don't know how it is that this is complicated, and in case Trey is confused, when a cliff face collapses, pushing back the cliff face, that doesn't make the rock that fell or the rock that remains younger.
So we've seen, I actually have a list here, if you don't mind, a list of some of these major collapses.
What a weird thing to have a list of. Imagine thinking that just listing off cliff face collapses was some kind of argument for the young age of the Earth. It's just an extension of the absurd idea that the Earth can't be any older than its youngest feature. Of course, this is obviously false. To use the above Hawaii example, Kilauea eruptions usually result in expansions of the size of Hawaii Island, or as it's also called, the Big Island. That means that there is currently land in Hawaii that is only a few months old most of the time. Does this mean that the Earth can't be more than a few months old? No, of course not. That's stupid. Similarly, if one could prove that no cliff formation on Earth could have existed as cliffs for more than, say, a few 100,000 years, that would do nothing to suggest how old the Earth is as a whole. New cliffs can form from things like uplift, sea level changes, or even erosion hitting harder bits of rock resulting in what was once a gentle slope, turning into a steep slope. Which is basically what a cliff is, a location where there's a steep change in elevation.
Of cliff sides, the Broadchurch cliffs that have collapsed twice in 2017 and 2023, the White Cliffs of Dover, 2001 and 2012, the Australian coastline, 2005 and 2009.
I don't know, I feel like Australia isn't encompassed roundabout with cliffs. In fact, there's a somewhat obscure city in Southeast Australia, in New South Wales, that has numerous parts of its coast that just gently slope into the ocean. You probably haven't heard of it, but it's called Sydney, and it has beaches like Bondi Beach, Clovelly Beach, Coogee Beach, Little Kongwong Beach, and Rose Bay Beach, which are not in fact cliff faces, although there are also cliffs around Sydney too.
That's all just within the last couple of decades. And so that is erasing what is supposedly millions of years of geologic history.
Yeah, when rocks are destroyed, they take that bit of geological history with them. That's why we have more or less no rocks from the formation of the Earth still around. It's almost like this is part of the well-understood rock cycle.
And am I right in saying that?
Well, that's correct. I mean, maybe at least
from their point of view,
right,
yeah,
hundreds of thousands or maybe even millions of years, because those cliffs, supposedly, we always were taught in school, like you were,
taught by big geology. They're always trying to get one over on the good Christians. The USGS is a tool of Satan, and you must flee to the protection of Christ, lest ye be led astray by the stratigraphy maps of the devil.
That those cliffs erode really slowly. But when you actually examine them for 50 years or 100 years or more, we're seeing it's a lot quicker than they.
The current erosion rate of, say, the White Cliffs of Dover are at about 220 to 320 millimeters per year, or, for my American viewers, about 8.7 to 12.6 inches per year. But this takes into account cliff collapse. Between cliff collapses, the erosion rate is far, far slower. It's an average, not a continuous rate. Let's use an example with food. Say you make a burger that weighs 300 grams, and it takes you 10 minutes to eat it. That means that the consumption rate was exactly half a gram per second. So when you ate that burger, were you trickling it into your mouth a half a gram per second? I sure hope not. Chances are that every once in a while you took a bite that was a few dozen grams. But does that mean you should measure your overall consumption rate at like 20 grams per second because that describes your bites from the burger? Obviously not. That's how it is with cliff collapses. They're not constant, they're rapid changes that occur only occasionally. Young Earth creationists just cannot seem to understand how measuring something happening over time works. I guess that makes sense given that one of the core aspects of being a young Earth creationist is being wrong about the timescales involved in real life. Also, I want to point out that in the last couple centuries, the rate of cliff erosion in many places has increased as a result of sea level rise, as well as coastal human activity. So using the current rate and extrapolating backwards in time is inappropriate. For example, before the late 19th century, the White Cliffs of Dover were eroding some 5 to 10 times more slowly.
Thought than they say.
Right. And so these cliff collapses, these erosions, even at current rates of erosion,
which, let's remember, is quite high.
I see like the continents wouldn't be here at all, right? If we follow that.
No, that's dumb. Phoenix, Arizona is both one of the driest and hottest cities in the United States of America, and indeed the world. It routinely has summer highs in excess of 45 degrees Celsius, with 49 being a temperature reached in most years at the height of summer. It also has an average humidity of about 30%, but in the summer it can drop below 15%. As a result, most pools lose about 2 meters of depth to evaporation per year. As a result, we can say with confidence that since more or less no pools open to the air in Phoenix are more than 4 meters deep, that there simply are no full pools in Phoenix, given that the city was founded in 1881, and any pools there would be completely dry by 1883. Or perhaps it simply means that if you find a pool with water in it, that proves Phoenix couldn't have been built before about 2 years ago. Obviously, this is stupid, and for a very obvious reason. People fill up pools when the levels get low. That's it. That's the whole solution to the paradox of the existence of pools in Phoenix and the old age of the city. at least compared to the age of most pools. It's the same with continents and erosion. Yes, erosion does take away land area, but uplift and volcanism add more land area. In fact, the big island of Hawaii has an effective erosion rate of negative 42 acres per year, or negative 17 hectares. That is to say, the island is getting bigger each year.
Most of the continents, except maybe active mountain areas.
Okay.
So that's really what's been measured. And I think there was a study done in 2011, probably one of the more recent studies, and they showed that the average rate of erosion on the surface of the Earth above the sea is about 40 feet per million years. That's their estimates.
That's pretty slow, especially given that we know that even if that is a normal rate, there will have been times when uplift and volcanic activity was higher than the rate right now. So there could be whole stretches of millions of years when the rate of erosion was much slower than the rate of continent building, just like it is in parts of Hawaii.
Slow, but over millions of years of time, that's a lot of erosion.
Right.
Right.
Whenever he says anything, you say right, Brett. You know that?
Right.
So you're looking at areas in the eastern U.S. that have experienced no uplift, even in the conventional time of about 250 million years or more.
Yep, in fact, the Appalachian Mountains, the Scottish Highlands, and the Atlas Mountains in Africa are the remnants of an enormous chain of mountains that formed when Pangaea came together, and at its greatest height, this chain of mountains would have dwarfed the modern Himalayas.
Maybe 300 million years since the Appalachians were supposedly formed that long ago. We don't believe that, but
Yes, Timothy Cleary is loudly and proudly wrong about basic facts of reality.
that's what they say.
Right.
And so the area, the East Coast, the Midwest, all those areas were exposed for several hundred million years.
Well, yes, but I do want to point out that much of the eastern part of North America is actually experiencing uplift. This is essentially rebound from the depression of the crust and the area as a result of the glaciers from the last glacial maximum. This is why places like Pennsylvania and Massachusetts experience infrequent earthquakes, despite not really being on or near the boundary of two tectonic plates. Indeed, Pennsylvania suffered a magnitude 5.2 quake in 1998. That's not a catastrophic event, but it's not exactly nothing.
Well, if it's 40 feet per million years, there should almost be no continent left. It should be right down to sea level.
Well, first, we know for certain that that's not how it works. Erosion rates are highly variable and are accelerating in many areas of the world as a result of both human economic activity directly and indirectly as a result of climate change bringing higher seas and more severe and more frequent weather events. Further, the areas undergoing uplift now are not the same as the places undergoing uplift in the past. Cleary is just factually incorrect in stating that the consensus is that the Appalachians have not experienced uplift since their formation towards the early part of the Paleozoic, followed by their breakup late in the Mesozoic. By the beginning of the Cenozoic, the mountains weren't mountains anymore. They were low-elevation hills bearing the marks of having once been mountains. It wasn't until the Neogene some 15 million years ago that uplift picked back up and continued until about 3.5 million years ago. Meaning that even if we take the 40 feet per million years as the gospel truth of erosion for all time, that's only about 140 lost feet of elevation since the most recent uplift in the Appalachian region. Which doesn't seem all that crazy now, does it?
In that amount of time. So if you do the math, it really adds up to a lot of hundreds of feet of erosion.
I did do the math, and while 140 is more than a single hundred of feet, I'm not sure I'd call it hundreds. Indeed, I checked with Benthoven, no relation, a native English speaker, and he said that the minimum he thought could reasonably be described as hundreds is 200.
And most of that area in that continent is only 500-600 feet above sea level.
I'd be curious to see where he got that number, because when I looked into it, it was more like 900 feet above sea level. But that being said, it just means that 3.5 million years ago, the mountains were on average 1,040 feet above sea level, which seems perfectly plausible to me.
Okay.
The Appalachians themselves are a little higher, maybe a little island string sticking out there, but the rest of the Midwest, my home state of Michigan, as you mentioned, that's 600-700, maybe 1,000 feet above sea level. That should have all eroded away.
Nope, because again, it has experienced uplift, but it's also the case that the lower an elevation an area is, the lower the rate of erosion will be. And as the land elevation approaches zero, so too does the rate of erosion locally. It's basically a consequence of potential energy. Since erosion fundamentally converts potential energy into kinetic energy, then to thermal energy, if there's more potential energy, then the energy gradient that the erosion is exploiting to do the work of moving material can sustain higher rates of mass flow. It's essentially the same as filling a bucket with water and drilling two holes, one higher than the other. The bottom hole will have more water flowing through it per unit time, even if you keep the bucket topped off. In fact, that's not a horrible analogy for erosion. The more potential energy, the more erosion there will be. But conversely, if you add more rock to the land being eroded, the total amount of land will increase or stay the same, despite even rapid erosion. Just like if you pour enough water into a bucket, it can stay full or even increase in level despite having holes in it.
and including most of the East Coast should be gone. We wouldn't have anywhere to live except maybe around the Rockies, which are more recent in terms of the geologic deep time
Yeah, but only if you keep ignoring recent uplift in eastern North America.
paradigm type of thing.
From their point of view, right?
So if there's no active uplift to rescue, we talk about rescuing devices, there's no way to rescue the eastern U.S.
Except that one, much of the eastern US is in fact undergoing uplift right this second, and that two, there is evidence of geologically recent uplift following erosion that more or less did erode that area flat, at which point erosion would be much slower. The thing is that this very question of how the Appalachian Mountains exist after all this time isn't something that no scientists have noticed or checked on. They have, and they know why and how they exist now. And this is another thing that comes up time and time again. Creationists will point to something about science that isn't immediately intuitive, and then claim victory without noticing or lying about the fact that, in fact, the real experts have known for a while why it is that it is the way it is, and that it doesn't really pose a problem for the basic picture of the history of the Earth or the universe that we can gather from science.
Because there hasn't been any active uplift in their time, 250 to 300 million years. So why do we still have these continents all over the world that haven't been active, geologically haven't been uplifted? Why are they still there?
We don't. There are no such continents. All continents are currently experiencing uplift in some regions, and likely always have been, at least since the crust broke into plates.
Right.
Right.
Before we dive into some of these, like, how do they answer this? Can you explain, like, what today that we see, not catastrophic rates, but just standard erosion rates? What causes that?
Mostly wind and water, although earthquakes and landslides have their part to play.
Well, just rain, heavy rainfall will wash things away, move things. Ice, you can argue the ice age moved a lot of material around, gets caught in the ice and gets transported. Or even say wind. Wind's not very effective, just mostly for small sand-sized particles.
He's obviously never experienced a sandstorm. I have. Wind isn't as big a factor as water, including ice, but let me tell you, it's not nothing either.
But for the most part, it's water. Big floods, major local floods.
The Mississippi carries some 550 metric tons of sediment each year, and this does not depend on floods. Floods sure are significant erosional events, but they are not the cause of most erosion. Indeed, just like geology says happened in the past, normal everyday weather and water flow causes most erosion.
All these types of things, you really can move a lot of material very quickly in a short amount of time. You go back to the classic studies at Mount St. Helens even. In 1982, the second eruption after the 1980 eruption.
Which, added material on the whole to the surface of North America, even if it did reduce the height of the mountain itself. But you know who doesn't need basic erosion explained to them like they're 3-year-olds? My subscribers. So why don't you hit that subscribe button below this video, and while you're there, please turn on notifications and like the video. That way YouTube will be more likely to tell both you and others when I have more content.
The ice that had built up in the crater melted away real quickly from this big slurry and carved about, I think it's a 140-foot deep canyon.
Canyon is a bit of a stretch. It carved a 140 or so foot deep, relatively shallow sloped sided depression out of soft, unconsolidated volcanic ash. And this is not a good analogy for the weathering and erosion of harder stones like granite, rhyolite, or basalt, or even relatively soft stones like sandstone or siltstone.
Like literally overnight. And some of that was solid rock, from previous eruptions.
No, virtually none of it was or is. Clary is just lying. The fact that the event he's talking about is a subsequent eruption after the more famous one of May 1980 should be the clue. The subsequent erosion, eroded ash laid down by that eruption or even later ones. The eruptions continued for some 11 years every once in a while. This means that the most time available for lithification of this ash was 11 years. While tuff is a kind of rock with a fairly short time of lithification, it's not that fast. And even if it were, tuff is a particularly soft rock anyway. Which again means he's cherry-picking an area with some of the fastest erosion possible, and then trying to extend that to a general rule. This is like me telling you that the average height of a human is about 122 centimeters, or 4 feet. But then when you look into it, it turns out that every last person I put into my calculation for the average height had dwarfism resulting from achondroplasia. It's pretty clear that I was just cherry-picking, just like it is with Clary here.
So under the right conditions, erosion can happen really fast.
That's true.
If you go back to the origin of deep time, and I wrote an article about this at our ICR, it's posted on our webpage. You can do a search under the origin of deep time. It was James Hutton, and he was in the later part of the 18th century, 1790s, he was proposing the Earth is millions of years old. He was trying to get away from.
Actually, he was proposing that there was no evident start time for the Earth's history, and that all the oldest geology he could see seemed to just be part of a cycle stretching back indefinitely into the past.
The Earth is millions of years old. He was trying to get away from the studies, or the written record in the book of Genesis.
Right.
He wanted to get that out of science altogether.
Well, yeah, it has no place in science because it's not a book of empirical data regarding the natural operation of the natural world, which is what science is. Millions of Christians, Jews, and Muslims have managed to accommodate the fact that a literal reading of Genesis isn't what actually happened in the past, despite it either being part of their scriptures or something that is part of their tradition, even if not being seen as directly scriptural.
And so, but he was looking at erosion in areas that were very, very slow amounts of erosion. And so he wasn't seeing even a rapid catastrophic event like a big major flood. He was just looking at day-to-day erosion in the fields and the hills and the rocks around Scotland.
Just like Darwin isn't the Pope of biology, Hutton isn't the Pope of geology, and pretending that his limitations and mistakes are relevant to modern geology is silly.
And he didn't really see evidence of any rapid erosion, so he was saying, well, that much erosion, to erode a lot of rock or deposit a lot of rock must have taken millions of years. He just threw that number out there.
No, he calculated it, and modern age estimates for the age of the Earth are not based on simply assuming some starting rock amount and then seeing how long it would take to erode down to what we have today. Hutton knew about uplift and sedimentation, so even he wouldn't have done that. He knew he couldn't, which is why he knew he actually had no idea how old the Earth was, just that it was much more ancient than people had thought up until his time.
That nobody can really fathom in their head, try to go home and think about a million years. You can't really grasp.
I can't even think of last week.
And so, I consider it like Monopoly money. You can't even, he just threw such a big number out there.
I'm sorry that apparently creationists can't understand numbers much higher than the number of fingers and toes that they have, but that doesn't really mean anything for the age of the Earth. Reality is under no obligation to make intuitive sense to Timothy Clary or to operate only at scales with which he is familiar.
And this is before they even had these, techniques where they can try to get that from their age dating, which is another whole story in itself.
And it's the reason we actually have reasonably well-constrained measurements of the age of the Earth, something Hutton never even claimed to have.
And so,
which we've talked about. We've had a podcast on dating methods.
Yeah, all the assumptions built into it.
Look, I'm not going to get into all the various topics surrounding radiometric dating. I'll just say this. Radiometric dating is a key part of basin modeling, which involves essential knowledge about the age of rocks. Without the ages being right, the model simply wouldn't work. And the thing is that the oil industry relies on basin modeling to find oil, meaning they depend on radiometric dating to work to find oil. Oil companies are usually only a few dry wells away from collapse because of how expensive drilling a new well is. The fact that they routinely use radiometric dating successfully to find oil should be all we need to say that when it's vital that the technique works, it does. That makes it reliable in my book, regardless of whatever complaints Clary might have.
But anyway, nonetheless, that's what he saw. Yeah. And so he kind of said that's slow erosion. That's what we see. But yet we don't really see evidence of slow erosion in the rock record. We see evidence of rapid erosion in many places.
Nice bait and switch there. We do see evidence of rapid erosion in some places, but we also see evidence of slow erosion. For example, the top of the Great Unconformity is full of glacial erratics, and glaciers are so slow that the word glacial means slow in English, as well as of or having to do with glaciers. Surprise Canyon is a paleo canyon that can be found cut into by the Grand Canyon, and like the Grand Canyon, it also has dendritic barbs and former tributaries, meaning it had to erode slowly. So when Clary, whom I'll remind you has a PhD in geology, said that we only have evidence of fast erosion in the geologic column and no evidence of slow erosion, he's lying to you. Further, when he implies that the reason that science has determined that the world is old is in part because of erosion rates, rather than things like sedimentation and lithification rates, he's lying to you.
Is kind of the name of the game. It just sits there, and then all of a sudden a big piece of the cliff will fall off.
It's great when a man professing to be a scientist doesn't understand how average rates work. Cliffs can sit unchanged for hundreds of years, and then suddenly a bit of wall will fall off. That means that the rate is averaged over those hundreds of years and is slow. The Old Man of the Mountain was a rock face in New Hampshire in the United States. It was first written about in 1805, but by that time it was already old enough to be well known to the local Abenaki natives as well as the Mohawk, even becoming the subject of legend, meaning it was almost certainly much older than that. In 2003, the cliff face collapsed. It was about 8 meters or so of cliff, meaning that if we just assume it formed in 1805, even though we know it's much older, then that cliff face has an average erosion rate of 4 centimeters per year. But we know it was there long enough to be a legend, which means it was probably there at least twice as long as its written history, meaning the erosion rate is probably closer to 2 centimeters per year. That this erosion happened all at once one day doesn't actually mean that the erosion of the cliff face as a whole is particularly rapid on a geological timescale. And remember, even the lower rate of 2 centimeters per year is probably low. Chances are that the formation didn't originate in 1607, as that calculation assumes, but probably much earlier. The actual erosion rate from the so-called rapid collapse could be orders of magnitude slower. That some kinds of erosion are characterized by sudden significant events between much longer periods of more or less inactivity doesn't really mean anything about the overall rate.
Yeah, big chunks at a time. So it's whether that's from, you want to call that the natural process over time.
As a matter of fact, yes, I would like to call that a natural process over time.
It is a lot quicker than what you think because it happens, big chunks will fall off these cliffs, as you mentioned, very, very quickly. Mm-hmm. And huge sections will fall off.
I both love and hate that he's just doubling down on not understanding basic math. This is the kind of math that kids in the United States are taught by the time they're about 13 years old.
Really, the Earth, I always say stuff like the Earth, like it's something, but the Earth really...
That was almost as coherent as the average stump speech by the disgraced 45th President of the United States.
Is built the way God built the atmosphere and the hydrologic cycle. It's built to destroy cliffs. The cycles will destroy cliffs, waterfalls.
I mean, yeah, cliffs aren't all that long-lived, and I don't think anyone is claiming otherwise. That's probably why there aren't a whole lot of paleo cliffs out there in the geologic record. But so what? That's just cherry-picking one of the most rapidly eroding things on Earth. If you asked me how long humans lived and I said 15 years, you'd find that odd. And if I told you that I sampled people with progeria only to get that number, then you'd probably think I was being intentionally deceptive, since only about 1 in 4 million humans are born with progeria. This is almost the exact same thing.
All these waterfalls we see over the Earth, all these cliffs we see over the Earth, those are temporary features. They shouldn't be there. They can't last for millions of years because they do erode so quickly.
Mm-hmm. Yes, because there are no mechanisms that can form new cliffs, right? Oh, wait, that's not right at all. Basically, all that has to happen is for there to be harder rocks behind softer rocks. And then the soft rock will erode first, leaving a steep cliff of hard rocks. And do we have natural ways for harder and softer rocks to form? Yep. Rock formation is well understood and not really disputed by young Earth creationists.
Yeah, we see them all over the world.
Pimples are a short-lived aspect of human skin. They are usually gone after only a week or so, and yet many humans older than 7 days have pimples. How is this possible? Sunflowers only live about 3 months after germinating. How can there be any left if the Earth is older than 3 months old? Milk, even if it's refrigerated, won't last much beyond a week and a half. How can there be fresh milk if the world is older than a couple weeks? Yeah, it's a big mystery.
We see them in Hawaii. We see waterfalls. We see lava tubes in Hawaii. I wrote another article about that on our webpage.
Wow, cliffs and lava tubes in Hawaii, a place full of active volcanoes. That's so mysterious. How could things formed by volcanoes be found where there are active volcanoes forming them?
There's a lot of evidence in Hawaii that it's very, very young.
Hawaii isn't a single thing with a single age. There are mountains in the chain stretching all the way back to Siberia. Each one as you go northwest is older than the ones before it. The Big Island is quite young, relatively speaking. Saying Hawaii is quite young is like saying humanity is a baby and then denying the existence of adults.
And part of it's the waterfalls and the cliffs. Mm-hmm. Those are very temporary structures that can't last for millions of years. They should have eroded flat by now.
I'm sure that the waterfalls in Hawaii from millions of years ago aren't the ones we have there now, especially since much of the rock in the southeastern portion of Hawaii have ages that can be measured in days or single-digit numbers of years. I mean, remember, the consensus age of the Big Island of Hawaii isn't even 1 million years. It's less than half that. So even if we shouldn't expect a single waterfall after 1 million years, which is nonsense, we should still have plenty of them.
Just like the continents themselves should have been eroded down.
Remember, kids, land only goes down, never up.
At their own erosion rates of 40 feet per year.
Per year, Dr. Clary? That's interesting, because at the beginning of this, it was 40 feet every million years. Convenient how we just dropped 6 orders of magnitude. That's a lot more than the 1 free order of magnitude I like to grant creationists.
And in some ways, Hawaii is even more interesting because you got these islands out there. They're supposed to be, Kauai is supposed to be around 5 million years old. And I think Maui is supposed to be 2 or 3 million years old. And Oahu is somewhere around 4, give or take a little bit. But they're very small islands.
They are now. They both grew from active volcanism and shrank as that stopped. For example, Kauai is some 5 million years old, but volcanism only stopped on the island some 400,000 years ago. That means that for most of the lifetime of the island so far, it was growing, not shrinking. So erosion rates are pretty much meaningless for this.
And they've measured the erosion rate since 1900 on the beaches, the beach erosion, which really is the erosion. The beach erosion on the islands of Hawaii, several islands, is about 0.4 or feet per year, or about 5 inches per year.
Okay.
So not 40 feet per year. Okay.
And so, it doesn't seem like a lot, but the islands are getting smaller every year by about 5 inches all around.
Wrong. As already stated, the Big Island is growing about 42 acres per year. It's not shrinking. And it's not like this is hard to notice. We have footage of spectacular eruptions on the island.
And if they're millions of years old.
And after millions of years old, I think that ends up being 76 miles in 1 million years.
Cool, but we don't need to go back that far. We'll use Kauai because it's the older of the islands Clary mentioned. In the 400,000 years since it stopped building new land, it would have lost about 36 miles of radius. It's currently about 33 miles across at the widest point and 25 miles at the narrowest. So in the last 500,000 years or so, it lost a bit over half its size, and it will probably be gone in another 300,000 to 400,000 years. That doesn't seem implausible at all. I really don't see what the problem is. An island grew to have an approximate radius of about 69 miles over the course of about 4.7 million years, then eroded to 33 miles by 25 miles over the next 0.4 million years. And let's remember, this is the worst case scenario since we know that erosion rates have accelerated in the last 150 years or so. Chances are that the actual erosion rate for most of those 400,000 years was 5 to 10 times slower. Our best case scenario is that the island actually only lost about 3.6 miles. I suspect it's far more likely that it was closer to 10 miles than to 3.5. But even if it's the full 36, then so what?
How big are the islands? I don't
Islands
know.
aren't that big.
Yeah.
Okay, but so what? If you had a block of ice that was losing 1 kilogram an hour of mass to melting, how old is the block of ice? Well, it depends on how big it was to start with. If it started at 4 kilograms, then it's only probably about 3 hours old. But if it started at an actual metric ton, then it's probably more than 41 days old. How big do Clary and Bowling think the islands are to start with? We don't know, and I suspect they'll never tell us. But all we need to account for a Kauai as big as it is now is an island about 70 miles across. The Big Island is currently 93 miles across at the widest point, and it's still growing. If its last eruption were today, it would take, at current erosion rates, some 760,000 years to shrink to the size of Kauai. This is just unit conversion and basic algebra. You could literally debunk this with access to the internet and a level of math skill typical of a 13-year-old American child.
And so there should be no
Small.
islands at all. There should be
Yeah.
no islands at that rate, which has been measured for over 100 years now.
Okay.
Non sequitur. Your facts are uncoordinated.
And so, you can't argue that there hasn't been any waves. You can't say the wave patterns changed, that the oceans were always there, presumably even in deep time.
Well, no one is saying that the waves didn't exist, although I can absolutely say that the wave patterns may have changed, but they don't need to have done so. Nothing about the observed erosion rate is problematic for the standard model of the origin and age of the Hawaiian Islands.
And so why are these islands there? The volcanic activity stopped millions of years ago on some of these islands in their worldview.
Nope, Kauai is the oldest Hawaiian island, and volcanism stopped there less than 500,000 years ago.
So why are they still there?
Because they haven't been eroding all that long. But there are lots of islands that are now gone. You can see them in this topographic map. Those are the even older islands.
The only island that should be there or could still be there would be the Big Island, where you still have active volcanic activity.
Right. Creating new.
But the others should be gone. They should become seamounts, like we see, further west of Kauai.
That is only true if he's going to give us the starting size of all the current islands besides the big one at their maximum size. And then he tells us how he knows that. He hasn't even tried.
You see just seamounts.
Interesting. Okay.
But we do see seamounts, and Clary admitted as much. I don't understand how the fact that we see seamounts and islands is somehow a problem. It's basically just asking why now is now. I don't know how to even begin answering that question. Maybe time is just fake. Yeah, that's it.
So I've actually heard of a couple of counter arguments for this.
I hope one of them is that Clary hasn't even provided enough information to establish that his version of the history of the Hawaiian Islands even is a problem in the first place.
One that I've seen is that actually the erosion rates were even slower in the past. They're much more quick today because of the way we do modern agriculture. So
Well, for one, that's almost certainly true, but even the modern erosion rates don't preclude the existence of islands or continents, because again, new land is produced. Lex Luthor in Superman Returns was wrong. New land is indeed being made all the time.
Well, and that may be a little bit of truth in that. I mean, there's, we stir up the soil some more a little bit, and so you allow more of our soil to wash off, but it isn't really increasing the erosion rate of the rocks.
Of course it is. The soil being in place protects the underlying rocks. If the soil erosion rate goes up, it uncovers rocks, increasing the weathering suffered by the rocks. You'd think as a PhD geologist, Clary could say something that's correct.
Okay.
Yeah, people argue in the islands maybe because we're stirring things up a little bit, but you're not really eroding away. It's the waves are still the waves, and the wave action, the wave erosion is probably fairly consistent. When an island comes up, it's going to be, that particular area, the waves and that latitude and longitude. That's kind of what it's been at, and over several million years.
Well, except the storm rates and strength also matter to long-term island erosion and are both on the rise as climate change marches on. But again, we don't need slower erosion rates in the past, really, since there was no attempt to give a starting size for the continents or islands so that the current rate could even be argued to be a problem. You know what, though? That's about all I can take for today. I'll catch you next time when we finish up this little fiasco of a podcast, or rather as much of it as I can stand, because it gets very repetitive. If you liked this video, please hit the like button, and if you hated it, please hit the dislike button and let me know what the problem was in the comments. Either way, if you're not subscribed, please do so, and make sure to turn on notifications, because if you don't, then subscribing, apparently, is fictional here on YouTube. Stay safe out there and have a great rest of your day. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tovend, Phil Rivara, Tapioca Weasel, Whispers, E2V, Strawberry Vein, Denny5252, Aileron Teller, Horseflesh, Ian Chen, Kelvin Brostick Van Manen, Landon Knoll, Mabbity Babbity, Monkey They Them, Sphincter of Doom, and Volus. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.
How